Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello, ladies and gentlemen. In this special occasion on the 5th Borobudur International Symposium 2023, allow me first to thank you to Unima as a host for giving us the opportunity to present our research entitled Comparison of Total Suspended Solid, TSS Reduction in Acid Main Drainage Using Alum and Ecoenzyme. The research was done by me, Christin Palit, as presenter, Mrs. Sulistia, Mr. Reza Rayanto, Kevin Nathaniel from Department of Mining Engineering, Faculty of Earth and Energy Technology, Universitas Trisakti Jakarta, Indonesia, Mr. Bambang Kholis Suudi from Department of Industrial Engineering, Faculty of Industrial Technology, Universitas Trisakti Jakarta, Indonesia, and Mr. Sarul Nizam Ahmad from School of Chemistry and Environment, Faculty of Applied Science, University Teknologi Mara, Shah Alam, Selangor, Malaysia. Okay, ladies and gentlemen, now we are going to move to the main presentation of our research. This presentation divided into 5 parts that consisting introduction, research objective, research methodology, result and discussion, and conclusion. Now we are moved to the first part, introduction. Minor activities often generate liquid waste as acid main drainage EMD with a very high concentration of total suspended solid TSS, which causes environmental pollution. Waste treatment of EMD to reduce TSS level is usually carried out by using alum. However, the application of alum has the effect of forming a crust on the bottom of the pot. Therefore, experiments are needed using materials other than alum, including coenzyme. Ecoenzyme is a complex organic liquid that contains a number of organic acids. For example, acetic acid, citric acid, oxalic acid, and malic acid. Ecoenzyme also has enzyme activity, for example, the activity of lipase, amylase, protease, and cellulase. With the existence of organic acid and enzyme, ecoenzyme can be utilized as cleaning agent and waste processing agent. Also has a nature of antibacteria and antifungi. So, based on our introduction, our objective is how alum and ecoenzyme affect TSS reduction in acid main drainage management. The third one is research methodology. They are divided into two. First one is materials and the second one is method. In the materials divided by three, one is production of ecoenzyme. The second one is characterization of ecoenzyme. And the third one is EMD sample. The first one is production of ecoenzyme. This is the figure of production of ecoenzyme. As you can see in the figure, you must prepare water, sugar or molasses, and organic waste. The first, you must mix well the ratio of water, organic waste, and molasses or sugar, which 10 to 3 to 1, and then ferment for 3 months in airtight plastic bottle. So this is the result of our ecoenzyme. The next one is characterization of ecoenzyme. Ecoenzyme characteristics include pH, density, total suspended solid, total dissolved solid, biological oxygen demand, chemical oxygen demand, enzyme activities, and killing power against bacteria measurement. The third is EMD sample. Our EMD sample were taken from PT Banjarsari Pribumi, South Sumatra, Indonesia. The initial characteristic of the sample have a pH of 5.2 with a TSS concentration of 1,200 ppm. This is the sampling location, and this is the sampling of our EMD. Next is method. We use several methods for our research. The first one is enzyme activity testing. It was conducted by using GNS method. Second one is killing power test against Escherichia coli and Pseudomonas aeruginosa bacteria was conducted by using ASTM method. The third one is TSS red rating was conducted by using SNI method. The fourth is treatment of TSS with alum is divided by three treatment. The first is treatment with varying doses of alum. Second one is treatment with varying of contact time. Third is treatment with varying of pH solution. The last is treatment of TSS with ecoenzyme. This is divided by 3-2. The first is treatment with varying doses of ecoenzyme. Second is treatment with varying of contact time. And the last is treatment with varying of pH solution. And next is result and discussion divided by 3. The first is characterization of ecoenzyme. Second is result of TSS treatment with alum. And the last is result of TSS treatment with ecoenzyme. The first one is characterization of ecoenzyme. This is the table 1 about characterization of our ecoenzyme. This is the parameter that we analyze, and this is the test result. Second one is result of TSS treatment with alum. There are 3 graphic here. You can see there are figure 5 is about result of treatment with variation in alum weight. Figure 6 is result of treatment with variation in contact time. And figure 7 is variation in pH solution. So, based on the result of the EMD treatment experiment using alum, the optimal operating condition were obtained at a dose of 0.03 gram per 200 milliliter AMD at a contact time of 5 minutes, and pH of the solution is 7 and a shaker speed of 100 RPM. An average removal TSS was obtained from 1,200 ppm, 202 ppm to 30 to 95 ppm. So the TSS reduction percentage between 92 to 97.5%. And the weight of the sediment produced under this condition is between 1.9 to 2.3 grams per 200 milliliter AMD. And the last result of TSS treatment with ecoenzyme, there are 3 graphic 2 in figure 8, figure 9, figure 10. Figure 9 is result of treatment with variation in ecoenzyme volume. In figure 9 in variation in contact time, and figure 10 in variation in pH solution. So based on the result of the EMD treatment experiment using ecoenzyme, the optimal condition were obtained at a dose of 10 milliliter ecoenzyme per 200 milliliter AMD at a contact time of 5 minutes and a pH of the solution 4.5 and a shaker speed of 100 RPM. Average removal TSS was obtained from 1,200 ppm to 40 to 80 ppm. So the TSS reduction percentage between 93.3 to 96.7%. And the weight of the sediment produced with this condition is between 0.3 until 0.8 gram per 200 milliliter AMD. From the result of this research, alum and ecoenzyme have almost the effectiveness in reducing TSS in MD. The advantages of ecoenzyme compared to alum are as follows. First, ecoenzyme have better economic value because it was made from fruit peel, which is fresh fruit waste. It is cheap, easy to make, and easy to obtain. Second is the use of ecoenzyme in AMD treatment also helps reduction of organic waste. With the increasing need for ecoenzyme, organic waste will increasingly be reduced and have an impact on improving the environment. The third is the use of alum causes mud deposits. From the experimental research, is use alum for 200 milliliter of AMD produce a precipitate of 1.9 to 2.3 grams. Meanwhile, in the treatment using ecoenzyme, the precipitate obtained was 0.3 to 0.8 grams. So this is the last conclusion. There are 4 conclusions. The first one is alum and ecoenzyme have almost the same effectiveness in reducing the SSEMD. Second is ecoenzyme have better economic value because it was made from fruit peel, which is fresh, fruit waste. It is cheap, easy to make, and easy to obtain. Third is the use of ecoenzyme in TSS treatment also help reduction of organic waste. With the increasing need for ecoenzyme, organic waste will increasingly be reduced and have an impact on improving the environment. And the last is the use of alum in TSS treatment causes more deposit compared to the use of ecoenzyme. So this is our presentation. I hope our research that we present today can contribute to sediment drainage management in the mining industry. Thank you for listening. Goodbye and wassalamualaikum warahmatullahi wabarakatuh.